Resuming with problem C. This is a function operation problem because I'm taking function g divided by function f. D is also a function operation problem because I'm multiplying function h by function f. So first we need to just carry out the operation and say, all right, what is function g divided by function f? Well, function g is that square root guy, so square root of 2x minus 7. And f of x is x squared. And can we simplify that? That's a no. So great, that's what happens when we divide those two functions together. So the operation part isn't bad here. So if you're like, all right, where does it get bad? It gets bad when you're trying to figure out the restrictions because I have to combine the restrictions for all of the functions involved. So first, does g have any restrictions? Yeah, it has the fact that x needs to be greater than or equal to 7/2. So I'm going to go ahead and draw the number line thing because you guys know I love that. Here's 7/2 with a closed dot since it's included, going to the right. Does function f have any restrictions? Nah. So function f, nada. But I have to consider any restrictions on the result. So looking at what I actually boxed, which was g of x over f of x, does that have any restrictions? So it's got the same square root, so it's going to have that same restriction that x needs to be greater than or equal to 7/2, so we can just put that right on top of my other one. What other restriction does it have? X cannot be 0. So the division one is especially evil because 90% of the time it's going to create another restriction with the result. So x can't be 0. So is 3/2 to the left, or sorry, is 0 to the left of 7/2 or to the right of 7/2? To the left. So it's just chilling over here. Does my domain start at negative infinity? No, this car is going to cry about that one. Does it start at 0? No, and if you're like, but dot there, there's a dot there. Yeah, we can't have that dot, but that dot doesn't even matter because my square root function is restricting it anyway. It says, yeah, we know we can't have anything over there. We already said that. It has to start at 7/2 and go to infinity. So my domain is bracket 7/2 infinity. The number lines help you put all those restrictions together. Questions there? Skedaddling on down to problem E. Actually, problem F. We're going to find the composite. So looking at problem F, we want to find h of g of x. So h of g of x. So this means I'm going to plug the g function into the shell of the h function. So my h function is 1 over x squared minus 9. The shell of the h function is 1 over an input squared minus 9. What are we going to put in for that input? Perfect. Square root of 2x minus 7. So what made me really sad is on the part of the test with composite, some people were like, I'm done. I'll put the function into the other function. We're good. But the question is, can I simplify that?
Yeah.
We can. The square cancels out the square root, first of all. Goodbye. So 1 over 2x minus 7 minus 9. Can I simplify that a little bit further? Yeah, 1 over 2x minus 16. The next step I do not have to do, but I'm going to do since we're doing all this restriction stuff. I'm going to factor the denominator, which I can do by taking out a GCF of 2. So then my composite h of g of x is equal to this. So that's my composite equation. Now for the restrictions. Who's our inner function in this problem? G of x. So the inner is g of x. So does g of x have any restrictions? Yeah. X needs to be greater than or equal to 7/2. Yes. So even though we don't have a square root in the final composite, because I'm streamlining these two functions together, plugging into that original square root first still has that initial restriction. So inner functions restriction matters. And then the composite, which is h of g of x. Does my composite have any restrictions? X can't be close. It can't be 8 because that's what makes this denominator equal to 0.
What about the 2 then?
2 doesn't have a variable with it, so it's just 2. Now, what about my outer function with its restrictions of -3 and 3? It does not matter. The outer function does not matter here. It is just the inner restriction and the composite restriction. So, what does my domain statement look like? Where do we start? Bracket 7/2. Then what happens? A break at 8 with a parenthesis, because that is a restricted value. I can't be having it. So 8 is not included. Then union notation. Don't forget good old union notation to infinity. Folks, we'll go ahead and stop there before we break for lunch.